Number 18, graph the function and find the requested information. So number 18 is x squared minus 5x plus 6 over x minus 3. So, just like usual, we're going to factor if we can, so this numerator can be factored, and it will factor down to x minus 3, x plus 2. I'm sorry, x minus 2. X minus 3, x minus 2. And this is all over x minus 3. Now, we can cancel out here, which tells us that there's a hole located at x equals positive 3. We set this equal to 0 in order to find where the hole is located, so we can see it's at positive 3. And our remaining function is f of x equals x minus 2. That's all that's left of it. This has been canceled out, so we plug this in here. So we say this is going to equal 3 minus 2, which equals 1. So the coordinate of the hole is going to be at 3, 1. So now it's just a graph. So at 3, 1, I have a hole. And this function is f of x equals x minus 2. So we're going to go down and just graph this like normal, and there's just going to be a hole located at 3, 1. So down 2, the slope is up 1 over 1. Have a hole there, and it continues, and it would continue in the other direction as well. So this is what the graph of this function looks like. Even though we started with a binomial with x squared, they canceled to tell us there was a hole located at 3, 1, bringing this down to just a simple linear function here, the hole at 3, 1. Okay, number 19. Oh, I'm sorry, we didn't find the domain and range. Going back here. So the domain is going to be everywhere except the hole. So looking back at our graph, just looking at the domain, we can see that it's going to be all real numbers except x cannot equal 3, the location of the hole. The range is also going to be all real numbers, but y cannot equal 1, which is the location of the hole. So that includes our domain and range for number 18. Okay, now back to number 19. Graph and then find the asymptotes as well as the domain and range. Okay, so I always like to factor just in case. So this is, we can factor out a 2, x minus 2, but that's not going to do anything for us here. So where is our vertical asymptote going to be located? Well, it's where the denominator equals 0. So you can either set this 2x minus 4 equal to 0 or just x minus 2. You'll get the same thing. X equals 2 is the location of our vertical asymptote. And then our horizontal asymptote, going back to our diagram we had in a previous video. In this case, the powers are the same. Top and bottom, they're both x to the first power. So when the powers are the same, that's this situation here, we look at the coefficient on those x's. So the coefficients here are negative 4. So the horizontal asymptote is going to be at y equals negative 4 over 2. We took these two coefficients right here. All right, so we need to graph this. So I'm going to this is going to simplify to negative 2 as well. Okay, so our horizontal asymptote is at y equals negative 2. Our vertical asymptote is at x equals positive 2. This is a negative function, so it's been flipped across the x-axis. You have that leading negative 4 right there. So our function's going to, I'm not going to plot points exactly right now, but it's going to look something like this. So we can get the idea. It's been flipped over the x-axis. The typical function, 1 over x, is going to look like this. So we can see that it's been flipped over because of that -4 that we have right here. All right, so our domain and range. The domain, so we're not looking at this one anymore. This was just our example. The domain is going to be all real numbers except where the vertical asymptote is located, which is at x equals 2. So x cannot equal positive 2. And then our range is going to be all real numbers, but y cannot equal the horizontal asymptote, which is -2.